This talk focuses on understanding the effects of network outages on user experience in AR-based remote collaboration. This was a joint effort between the Networks and Systems Lab at Tufts University and the Center for Applied Brain and Cognitive Sciences. Remote collaboration has become critical for our daily lives, especially in the context of the COVID-19 pandemic, to support work from home and remote learning practices. New methods of collaboration, such as augmented and mixed reality, allow for more immersive and content-rich collaborative experiences. Prior work has used AR and MR technology to collaboratively visualize geospatial data or to teach surgical procedures using 3D models of the human body. A common constraint for all these applications is that they rely on the internet, and as the internet is a best efforts service, network impairments are inevitable and they can adversely affect user experience. While these effects have been explored in the domains of multiplayer gaming or video conferencing, AR and MR applications have largely been overlooked. This gap needs to be addressed to inform the design of future collaborative AR and MR applications. Our goal then is to understand the effects of network impairments, particularly outages, on user experience, and to evaluate the impact of giving users feedback about network state, all within the context of AR-based remote collaboration. In our study, we focus on internet outages because they happen all over the world and are a major issue in developing regions, and they can be difficult to deal with. Users are completely cut off from the network while the outage lasts. To achieve our goal, we designed and implemented a collaborative AR task. We kept the task simple to offset the difficulty users may face when using AR for the first time. Our task is also similar to commonly occurring collaborative scenarios, such as a teacher-student scenario or an expert-novice scenario, where one user is knowledgeable about a task and provides guidance and instructions to another user. We conducted an IRB-approved user study with 16 participants, 8 pairs of users. We recruited these participants from within and around our university community, and we qualitatively analyzed the results. Our collaborative task was as follows. Users worked in pairs to move virtual objects from one location to another. Users were wearing AR headsets and could see these virtual objects through their headsets. The goal was to move an object from its starting location, location A, to its ending location or a target location, location B. Each user had a specific role within the task. One user acted as a helper and another user acted as a worker. The images in the center show what the helpers and the workers could see through their headsets. The helpers could see the target locations for these objects, but could not move these objects by themselves. In contrast, the workers could move the virtual objects, but did not know the target locations. Therefore, the helper gave instructions to the worker, who then moved the virtual objects in order to complete the task. Our users were placed in different rooms to emulate remote settings. They could view the AR content through their HoloLens headsets, and they could only talk to each other through their headsets. This video shows an interaction from the perspective of a helper and a worker.
So you see your laptop?
Yes.
Okay, so you're going to want to grab that first, and you're going to, well, I'll just wait till you grab it. Do you have it?
I grab it.
Okay, cool. We want to go to the down and to the right. Cool. Yeah, let's keep going down. So you see your laptop?
Yes.
Okay, so you're going to want to grab that first, and you're going to, well, I'll just wait till you grab it.
I grab it.
Do you have it?
Yes.
Okay, cool. We want to go to the down and to the right. Cool.
Our users performed this task under different study conditions. In the first condition, They performed the task under perfect network conditions. This was to make them familiar with the task as well as with their partners. Our users then performed the task under outages. During an outage, users could not talk to each other, and if the worker moved a virtual object, the helper could not see these object movements. In the last condition, users experienced outages, but we also gave them some feedback about network state. The images on the right show different types of feedback. In one case, a simple message would appear stating that internet issues were occurring. In another, the message was accompanied with a timer that counted down to when the outage would end. We were interested in the following research questions. Number 1, what were the effects of network outages on user experience? Number 2, how did users adapt to network outages? And lastly, how did user behavior change when they were given feedback about network state? For this talk, we will only be focusing on research question 1 and 2. The full results can be found within the paper. To answer our research questions, we simulated 9 outages each in the condition with and without feedback. Each outage lasted for approximately 10 seconds. We collected first-person video recordings from each user's headset and had them fill out an end-of-study questionnaire, and then we performed a thematic analysis on the results. We found that users were affected by outages differently based on their role within the task. Our helper stated that they could not carry out their core responsibility within the task, which was giving instructions, that they had to perform extra work when repeating instructions that would go unheard by their partner, and that they could not accurately interpret task state. Our workers experienced increased uncertainty in their actions. They were unable to ask for help when they needed it, and as a result, they were forced to slow down or stop their actions altogether. To adapt to outages and their adverse effects, our users came up with the following strategies. They would batch instructions, so helpers would give more instructions when the network was available to make up for the time when they were unable to provide any help to their partners. Secondly, they changed their spatial referencing style. Helpers started using virtual objects as spatial markers or reference points when giving instructions. This helped workers carry on with the task even during outages. This video shows an example of a helper using virtual objects as reference points when giving instructions.
All right, do you see the laptop?
Yes.
Okay, so just grab it and then you're going to want to bring it. You see where the apple is as well? Hello? You get cut off?
Yeah, sorry.
Yeah, no. So where the laptop is, do you also see where the apple is?
Yeah.
Okay, so you want to bring the laptop, you're going to go past the apple, just to give you like a reference point.
Okay.
Yeah, that's good. What you're doing is great.
We came across some interesting questions when analyzing the results and proposed some design guidelines for future AR applications. Firstly, we wondered, what is the best way to utilize free time during an outage when users cannot communicate with each other? One approach is to shift a user's focus away from shared tasks to local subtasks that can be performed independently. Alternatively, gamification could be used to distract the user and prevent them from getting too frustrated during an outage. We also noted that some users did not notice every outage. This begged the question of whether we can hide outages from the user, perhaps by predicting an object's movements, in order to give them the perception that everything is okay. Some more questions and design guidelines are mentioned in the paper. While our study answered various research questions, there are some limitations and avenues for future work. Firstly, it would be useful to understand whether users perceive outages as more or less severe based on the duration of an outage. Secondly, we considered one type of collaborative scenario and focused on network outages. It would be interesting to explore the scenarios with a variety of interactions and to look at other types of network impairments such as packet losses or latency. Thank you for your time. For more information about this work, please use the email address given below. And for more video examples of the task, please visit our project webpage, and the link has also been added to the research paper.